Okay, welcome you all to yet another lesson on this Falcon 2000 aircraft systems. I find that there is a good response and good reception to some of the lessons which I put in Falcon 2000. Also, I find that not much of resources are available on the net. So, I decided to make further lessons. This lesson is about Falcon 2000 EXEZ fuel system. Okay, let's go to the lesson. Okay, as usual, the limitations. Here, I have tried to show some limitations figure of the total fuel capacity of the aircraft. Before going further, uh, I just want you all to understand that there are at least three different variations of this model which are available. That is the 2000 DX, EX, and LX. The basic difference between all of them is the basic fuel capacity limitations only. Fuel capacity limitations. So it's really no point for me to cover so many things, so many fuel capacity for all the types. Eventually you will be flying one type of the variant, and you are going to be familiar with those figures. Here I have given the figures so that you will get an approximate idea of the uh, fuel that is being carried in the EX version. So the total figure, if you see, is about 8268 liters or 6.6 tons, which works out to 14,640 pounds. So I put this so that we get a fair idea of how much fuel we are carrying in. So obviously the DX will be slightly lesser, and LX is slightly better, or LX will be very similar to this capacity, but with the winglet extension, you will get better endurance performance. So that's about the difference. So depending on the variant which you are going to fly, so you are going to get those figures. So the purpose here is to just give you an idea. Go through some important limitations. The amount of fuel left in the tanks when fuel quantity indicators reach zero is not safely usable in all flight conditions. So if when the fuel indicator reaches zero, you may as well assume that there is not uh, any fuel left. Don't consider it for further flights. In flight, the tank fuel temperature must be maintained at least 3 degrees above the freezing point of the fuel being used. Normally, you all know that it's about -50. So, minimum we must have a in-flight temperature above 3 degrees above the freezing point of the fuel being used. Maximum fuel asymmetry or desymmetry between the wing tanks is 2,200 pounds. Maximum feed pressure is 50 psi, 3.5 bars or 350 kilopascals. The fuel quantity management computer FQMC must be operative for takeoff. These are the important limitations. Let's go to the system. The fuel system uh, provides the engines and the APU with pressurized fuel. That is compressed air from the engine when it is running is tapped and it is routed through the to the fuel tanks to supply pressurized fuel to the engines and the APU. Now, pay attention to the diagram which is given. There is one yellow color which represents the right hand group which supplies the engine 2 and the APU with fuel. There is a right hand wing tanks, that is outer inboard tank, and there is a lateral tank, and then of course there is a right hand center tank, center wing tanks, and there is a front tank. Similarly, on the orange color, the left hand group is shown. Left hand group is very similar and to the right hand one, which supplies to engine 1. It has got left hand wing tanks, which is again subdivided into outboard and the inboard, and the lateral tank, and of course there is a center wing tank and there is a rear tank. So the only difference between these two is for the right hand side there is a front tank, and for the left hand side there is a rear tank. Here I have to show, I have tried to show the details of the fuel tank construction. The right side first, it's of course the schematic. Right hand wing outboard tank, as you can see, the inboard tank. And of course there is a small division, right hand wing lateral tank and right hand feeder tank or the center tank, to which the booster pumps are located. And of course there is a front tank. All these tanks are interconnected and the fuel is getting exchanged freely. So we are going to see that in detail as the lesson goes. I tried to show the left side tank in yellow color. Construction is very similar except that the left side tank has got a rear tank instead of a front tank. Obviously the capacities are slightly different, the working is slightly different, and which we are going to study as we go. So let's see the tank construction etc. in a little bit more detail. As I explained earlier, the fuel tanks are pressurized by low pressure bleed air from both the engines. Of course, this is independent of the air conditioning system and it is regulated at 2.9 psi and it is automatically controlled by the pneumatic system. So it's all pressurized fuel tank. Now let us get on to the fuel booster pumps. There are 4 centrifugal booster pumps, 3-phase, 115 volt, 400 hertz. It has got an integral inverter and 1 main and 1 standby in respective center feeder tank. The main pumps are set to on automatically when the engines are started, and of course the number 2 main pump where the number 2 collector tank supplies to the auxiliary power unit is set to on when APU is started automatically, and they are not put off when the engine is shut down or APU is shut down. So that's the mechanism. So it's all automatic and there are 4 identical centrifugal booster pumps, 2 in each collector tank. I have tried to explain the jet pump working in a bit more detail. The jet pumps use the Venturi principle using the motive flow. The main purpose is to ensure that the booster pumps are always immersed with fuel and it doesn't go dry. Of course, there are 6 pumps on the left hand side and 5 pumps on the right hand side. Now, let me take you to the construction of the jet pumps. Have a look at the diagram very closely. From the booster pump, either the booster pump or the standby pump, one of them is working. So fuel is being supplied under pressure. and it is being routed through a jet pump where the flow it is thrown back into the collector tank. Now that causes a, motive flow which sucks fuel from the other tank. As you can see in the top diagram, there are five such jet pumps which are connecting different sections of the wing tanks. That is the wing outboard tank, wing inboard tank, and of course the lateral tank and collector tank and the front tank. There are five of them on the right side. Uh, they all the fuel from such these tanks are sucked through Venturi principle and collected, and of course it continues to be routed throughout in the system. And of course you can see in the bottom there are flapper valves which prevents reverse flow of the fuel in case of any leak and things like that. And you can see that the bleed air from the engines is pressurizing the different tanks, and this is of course the schematic and little bit of explanation and to explain the working of the jet pump fuel. But I can tell you practically it's very effective, very effective, and it's one of the best systems uh, which the plane incorporates. Okay, let's see some cross-feed fuel transfer and cross-feed provisions which has been given in this in the fuel system. Fuel can be transferred from either center tank to either engine. That's how normal fuel systems are constructed. So there's nothing novel about that. But in this plane, you can transfer fuel from right group to left group. So that's something unique to this particular type of aircraft. So you can transfer and equalize fuel at any point in time. Operation of the crossfeed inhibits the front and rear jet tank pumps. Therefore, it is not possible for us to transfer fuel from the front tank to the rear tank. So these are the transfers which are possible, but practically I can forewarn you that this transfer of this one group to another, that is the right group to left group, the pilot needs to be very careful, because at some point the rate of transfer becomes fairly high, and unless you're watching the transfer figures closely, you can overshoot your estimates, and therefore I will expect that you pay close attention whenever you're doing group to group transfer, which normally you would do only in ground. In air it is not recommended for because of course, as you know, 2200 pounds difference is fairly a good difference to fly with, so there's really no need. But should you be needing, you need to pay a close watch on the transfer figures and quickly stop the transfer operation if we are doing fuel transfer from right to left group or left to right group, vice versa. Next, the fuel quantity management computer. As we saw, it's one of the limitations, and if it is not functional, you can't take off. What are the functions? Monitoring of the fuel gauging and flow metering, low level management, refueling control of valves, fuel used in computation, fuel temperature measurement, center of gravity monitoring, monitoring of the engines and APU oil levels. So this is something unique. It's a single computer. Uh, in fact, it is frequently referred to as fluid quantity management computer. So it monitors the oil levels also, APU oil levels, systems self-monitoring and management of level of hydraulic reservoirs. So in fact, all the fluids of the plane, this single computer is measuring and managing it. I've shown the location of the fuel control panel on the overhead panel where it is located, and I just want you to have a look. Of course, I'm going to explain the details of the fuel control panel per se shortly. Go over the controls in a little bit detail. Um, First is the tank crossfeed indications and the push button. So it's a push button which you will initiate the action, and of course the amber cross cross TK light will appear when you are doing the transfer operation. The next is the standby pump on indication. That means under normal circumstances standby pump is not working. For some reason, if there is a problem for the main booster pump, the standby pump will come on and this light will come on. So indicating to the pilot that the standby pump is working. Now booster pumps push on off button, as I told you, they are initiated automatically when the engine starts or the APU starts, and shut off manually. And here I have shown the cross feed indications, that is from one group to the other engine. That is the cross feed push button. So these are the standard controls which is with the pilot. But practically most of these controls are automatic. So for day-to-day operations, there's nothing one needs to do, and it is all controlled automatically. Have a look at this page. This is the synoptic page of the fuel system, and I want you to have a detailed look. Of course, I'm going to explain it in detail, but nevertheless, you can have a look before I commence my full explanation. Okay, let me explain the synoptics page of the fuel system in brief. Let me go over the indications one by one. Firstly, the booster pumps indications. There are only two of them are shown, even though there are four booster pumps shown in yellow square. And the cross booster pump valve, that is from one center tank, one collector center tank to the other engine. The cross feed is shown. The cross tank valve, as I was telling you, that we can equalize fuel between the left tank and the right group tanks. So that is the one which is shown. Now the fuel used, if I you can just see below the engine 1 and engine 2 indications, it will show the actual fuel used at any point in time once the engine starts running. So that is the fuel used indications. And there are two soft keys labeled wing 1 and wing 2. So if you take the cursor there and press it, there will be a pop-up window which shows the details of the fuel contents in different tanks. That is the outer tank and inner tank, center tank, feed tank, and wing one tank. Similarly on the right side. And there is another reset fuel used soft key on the right side, if you can see. This on ground, for some reason, if it has not been set to 0, pressing this will reset to 0. Obviously, this cannot be reset in air. Also, there is another yellow line in the tank depicting the fuel low warning, that is 250 pound low level warning line. The working of this and working of the system we are going to see in another lesson. let's see some more places in the cockpit where the fuel indications are available. Firstly, the engine trim brake. On the engine trim brake also, the fuel used and fuel quantity figures are reflected. I have highlighted in yellow square. Also, in the HSI on the left side, again, FQ and FR are reflected. Fuel quantity monitoring is a very important aspect, and therefore such indications are given. And also there are CAS messages which will appear if there are any warning or caution to be provided to the pilot. See some more system components. Negative pressure relief valves. Each wing outboard tank has a negative pressure relief valve to ensure that the fuel tank pressure does not drop below the atmospheric pressure. And of course, there are some drains to collect fuel. There are 10 points, 10 such points underneath the fuel tank to collect such samples. Okay, some more pressure relief valve. There are three vent valves. One on the left hand side, right hand side, and the rear tank. As we learned that the tanks, fuel tanks are pressurized from the engine compressed air, and maybe there is some residual pressure all the time remaining in the tank. So before refueling operations, the pressure has to be equalized. So these are commanded to open position when the aircraft is on ground, and the refueling coupling lever is set to open position. So in fact, when you open the refueling panel door and the thing, you can hear the pressure getting relieved, and sometimes it is possible that it's not getting relieved. That's one of. Okay, we just saw the construction and the components of the fuel system. I hope you enjoyed going through the lesson and found it useful. So please feel free to offer your comments and critical comments, especially to the mail ID given here. And this is going to be followed up with two more lessons where it will cover the normal operations and the abnormal operations. I thank you all for going through the lesson patiently once again.